Greetings, mathematicians of all ages. Today we're discussing variables and expressions. And a lot of times when we get to variables and hear variables, we get really intimidated because we know it involves those x's and those y's. And, we'd go into a different classroom and we'd see all those on the board and just get really intimidated because we don't know what's going on. You see like 5x plus 7z minus 2y, right? And it's easy to get really intimidated. The thing is, you've been using variables for a long time, probably since first grade. We just didn't use letters. So in first grade, your teacher would probably say something like, all right, class, take a look at this problem. 1 plus box equals 3. Who can tell me what goes in the box? And as a first grader, you probably weren't thinking, yes, my teacher put up a variable equation there, and I'm trying to solve for the variable box. You were probably just thinking, what do I put in the box so that they all add up to 3? And of course, you all raised your hands because in first grade everyone raises their hand, and you all knew that it was 2. Okay? Then in second and third grade, you may have been graduated into the question mark, also a variable, but your teacher didn't open the lesson by saying, today we'll be doing variable expressions involving question marks as our variable. She probably just said, or he probably just said, 7 times question mark equals 21. And in third grade, probably about half of you raised your hand because people are starting to raise their hand less. Maybe not. I don't know. And you all wanted to answer that question mark was 3. So this year we're doing pretty much the same thing, except that we're going to start using letters. We'll use other things too. But we're going to start using letters because that's how you're going to see it in the future. And it's going to be really helpful then. So in both of these cases, the box and the question mark, all a variable does is it holds the place of a number. So it represents a number. If you can remember that, I think it'll help you be less intimidated by variables. Just always remember, a variable simply holds the place of a number. It simply represents a number there. Okay? So now we're going to talk about something called variable expressions, but before we do that, I'll just get to something you've seen in the past, which is something called a numeric or numerical expression. And you've probably seen things like 8 plus 3 plus 2 plus 1. And this is a numerical expression because it involves numbers and operations. That's all it takes for it to be a numerical expression. A variable expression will include all those things, but it will also include variables. So a perfectly acceptable variable expression would be x plus 2. Perfectly good expression there. Z minus 9. And finally, let's go lollipop. Is that what they look like? Sure. Lollipop minus 4. All perfectly good variable expressions. These are the kinds you'll probably see in the upper grades because we like to use letters. They take less time to make than a lollipop. That's probably why we don't use lollipops as much. Anyway, let's get into how this is useful. And it's gonna seem fairly basic today, but it's really important that you get the basics of variable expressions and variables down so that later we can use them in things like algebra to save us a ton of time on problems right now that we have to use guess and check and tables on. Algebra will cut that time probably down 4 or 5-fold. So let's get into it here. So what I can do is start with a variable expression, and that can look something like x plus 8. And if I tell you what's x, it could be anything at this point because we don't have an equals sign symbol in that. There's no real way to know what x stands for right now. And we're going to get into that later. This section, all we're doing is getting used to the fact that variables hold the place of numbers. So what they're going to do is give us a variable expression, and then they're also going to tell us what the variable equals, and they want us to simply simplify the variable expression. So they'll say things like simplify x plus 8 for x equals 4. And all they mean by that is we want x to be the placeholder for that number 4. And what we want you to do is plug that 4 into the problem and then simplify it. I'm going to keep saying simplify, not solve, because to solve something you need an equals in the original, and we don't have an equals in the original. So we are actually simplifying here. Well, anyway, if I plug in the 4 for the x, 4 plus 8, we should all be able to do at this point. 4 plus 8 is 12, right? All right, let's do another. This time I'll use y, another common variable used, and I can flip it around. I can do 12 minus y, and again they're going to say 4y equals 3. And they want us to simplify this. From here over, this is all just giving us some information we need to solve the original. So once again, all I'm going to do is take what they gave me for y. I'm going to plug that into the original variable expression. So I just rewrite it, 12 minus 3, because I'm plugging in 3 for y. And that, of course, equals 9. Now, something, a new kind of notation that you will not have seen before is, in the past, your teacher would have said something like 4 times box equals, 8. And they want you to figure that out. In variable notation, variable expressions, we never actually use that symbol, and some of you probably see why. If I do 5 times x, you can probably see those are way too close. And so it either looks like 5 times times or 5xx. So to avoid that, what we do in variable expressions is that we simply smush the number, which is called a coefficient, but not terribly important that you know that right now. We smush this number and this variable right next to each other, and I read that 5x, but what it actually means is 5 times x. Okay, and so the book would say something like simplify 5x for x equals 3. And now we simply just do the same thing. We plug in 3 for x in the original, which would be 5 times 3, and I'm just going to show you a couple new ways to write it as you get used to not using this symbol. One way to write it is if we put it in parentheses right next to it. This means the same thing as this. When I have two numbers smushed together like that with parentheses, that means multiplication. So it can be 5 times 3 is 15. Another way to write it, which you're going to see a lot, is I actually use a small dot. 5 dot 3 also means multiplication. So these are just two new ways to write 5 times 3. We just don't want to use this symbol anymore because it's too close to this. It's also the reason when you see me write my x's, they look kind of cursive, if you will. I have some extra things on the edge just so people don't confuse it with that symbol. Okay? For now, division is going to look the same for you. They're going to use that divided symbol. So that could be, and let's just jump out of letters for a second. Again, a variable can be anything that holds the place. Let's do tree divided by, I think it's a pretty good tree, divided by 4. And this whole time I've been saying 4 tree equals something. Another way to write that, rather than putting the word 4, they might just put a comma or a semicolon or something and then just say tree equals 20. This semicolon means the same thing as 4 tree equals 20. They're just saying this is still the original variable expression, and now they're telling you what the variable is holding the place of. So now I plug it in, 20 divided by 4, which is, of course, 5. So hopefully you see today variables and variable expressions don't have to be intimidating. If we can really just get into our head that variables simply hold the place of a number, they represent a number, it's going to help us enormously in the future. I think it'll help us get less intimidated. So that's all for now. See you next time.